Got it.
Okay, so hello everyone, and today we have the question left from what was announced some time ago, and it is labeled as education and cosmology, but actually all the questions are about the scientific methods or scientific approach. So let's start. The first question is, what is missing in education about the scientific methods? Vitaly, you mentioned some time ago that scientific methods are not being taught, so people don't understand how the science work, and what's the reason why people questions, and that's the reason why people question science. What is that? What do you think to be missing?
Well, yeah, let's see. So there are two questions here. What is missing in education and what is the scientific method, right? So maybe we can split that. So in my mind, the scientific method is the ability to take some kind of mathematical formalism, apply it to modeling the phenomena, right? So it doesn't matter what your mathematical formalism is. It doesn't matter which phenomena you want to model. If you are successful in that, that's your theory. That's a scientific method. Now, why do you need to model phenomena, meaning something that you can observe? Because that's the only way for you to check that it is science. Now, if you are modeling something that cannot be checked by the experiments, you may be modeling something, but it wouldn't be called, it maybe it's like some kind of philosophical aspects, but it wouldn't be called science. Now note that currently we've advanced science so much that very often we use in our modeling things that can never be checked experimentally. Like nobody had observed gluons or directly, right? Or Higgs particles directly. But that's okay, as long as there is something that you can check experimentally. So you have a mathematical model, from that you build your theory, and then you apply it to experiment. As long as there's something that you can explain or predict, then it's science. Now, people confuse for what science is able to do and what is not able to do. So very often they make statements, science proved something. Okay. Now, science never proves anything, right? So what it does, it creates, takes this mathematical framework, it creates a model, and then makes predictions. And if these predictions are good, then most of the time your experiment will agree with your predictions. If they're bad, then you will see the opposite. So I guess that's one misconception with science that people say. So we don't prove anything; we just develop a theories that can probabilistically explain certain phenomena. And another, I think, misconception about science is because people try to draw a red line. Now, what is it that you're allowed to model, and what is it that you're not allowed to model with science? And they say there will be questions that science can never answer and shouldn't even try. So that I'm against that approach. So first of all, model whatever you want. Just tell me, what your framework is, what your assumptions are. And then if you're able to model more than my theory does, or my framework, even better. That's how science will make progress. So that's to answer the first part of the question. And so maybe we should discuss that first, if there are disagreement of what science is, before we move to education, because if we cannot agree that, we cannot educate anyone about that.
I have one question.
Okay, comments, questions, suggestions.
Okay, I would like to comment on the concept of a model. For it requires some further clarification, which models are acceptable, and for that have mathematical models. There is simple logic, for example, just basic propositional logic, and in some areas, in some sciences, it's difficult to move beyond this simple set of implications. So the first thing is that we have to warn that yes, it is also a model. However simple, it can be a model. And another question which appears just recently are the connectivist model, like large neural networks. They are models. They appear that they demonstrate some behavior. So very complex large language models. The question is what they have, what they explained really, what they're certainly significant for studies of a brain, for studies of a language, but so far it's very difficult to say what exactly the building of such a complex model demonstrates, what we can predict from these such models, except that they are possible. So the models are very broad class of objects, and so probably it will require some point to say what are good models, what are not so good models. Certainly the sets of differential equations are a classic scientific method, but other models probably can give rise to some other types of science. They all remain mathematical, but it requires some clarification, further discussion.
Yeah, I think that's a very good point. Now, let's say you have a mathematical framework which is very complex. You've done very complex calculation and explain one single phenomenon, nothing else. I mean, does it worth it? Does it worth investing time into mathematically maybe ugly model that has not produced anything new? So it has very large complexity. I would still call it science. So you still started with a mathematical framework to develop something, and it's working, even if it's a very complex and ugly neural network that does it. Now, but is it useful? And that's where there is no unique answer. There is no answer that will say, okay, this model is useful, and that is not until you try to generalize it, try to see it in different limits, and maybe something that doesn't look very pretty in the beginning and very compact at the end of the day will shed light on some phenomena that you were not able to do before. So I wouldn't disregard such complex models right away, but it is true that we should judge them using something that's known a Kam's razor principle, right? So if it is too complex and it doesn't really produce too much new results, then maybe if it has too many parameters or things like that people like to talk about, then maybe it just doesn't worth exploring it. But again, it's not a hard no, but it is something that is truly one has to look at.
It is very engineering approach to science. You look, there is not much difference between engineering and science with such definition.
Yeah, actually, I'll give you another example. So in the beginning of last century, we discovered field theories, and then there were few particles, few fields, and then the number of fields and particles kept growing and growing and growing. And yes, originally it was a beautiful model and it had few parameters. Then now the number of parameters grow, the complexity of the system of the standard model grows, and then you may say, okay, now it's bad. It used to be good, but now it's bad. Perhaps, but we have nothing better yet. And so at this point, we just have to work really hard. And then usually what happens then, all of a sudden, everything becomes reduced, right? Like in chemistry, you had lots of chemicals, and all of a sudden you understood that chemistry isn't that complex. You just explain it with a few more fundamental particles than molecules. And so that's the hope. But I don't want to stop people from making complex model if they're ugly, and it's actually good. But I think the problem with most people who try to write their own theories of everything or whatever, they do not start with a mathematical framework. They start from the answer We want to get dark energy, so I'll be explaining dark energy, but not from the core of the problem. And so, Alexander, you're raising your hand for a while, and Katya, as a moderator, didn't ask you to speak, so I'll jump in and do that. Okay, Alexander, go ahead.
Several questions, but I'll start with a comment from Steve Wolfram. Someone posted in the chat, watched the video, said, and he explains the entropy as he understands in the second law thermodynamics. And his point is that it's because of our computational irreducibility, right? Because of the way who we are, we perceive physics in this way, and we perceive entropy as growing just because we cannot calculate it back due to calculation irreducibility. So what's your view on that? That the physics as we understand it, as we model it, and thus all our models are derived by our nature, let's say.
Okay, so I think what you're making the point is that we are the people who are trying to model the universe, or we are constrained by whatever architecture that builds us, and apparently that architecture is the neural architecture, and so maybe some very simple thoughts that aliens with some other architecture can do, we're unable to do that. It needs to be shown if this is really a problem. Like example, think about using neural network theory, come up with an architecture of the neural network that tries to model the world with a constraint. So it is constrained not, for example, you can put a constraint on neural network, not allowing it to be deep neural network or only shallow, and then ask that neural network to model something, image recognition task, and you will see that seems to be like a simple task if you would allow the neural network to be deep, but very hard when it's shallow. So by having that architecture imposed on you, it certainly constrains the type of theories that you can develop. So I agree with that. Now, luckily, our neural network is not shallow; it's very deep. And luckily, I do not know of any constraints that are currently imposed on our architecture that would prevent us from certain type of information processing. So if we can discover that type of constraints but there is a constraint on our brain, right? It's a three-dimensional connections, right? So connectivity of our neurons is three-dimensional. We are embedded in this three-dimensional space. Now, if that provides a barrier to some kind of development of some kind of theories, then that would be very interesting to explore that.
Can this constraint be the level, our scale? I mean, if we build the neural network at atomic level, maybe we can, build a theory, quantum theory.
That's another thing. Maybe we are too tiny, right? We are too small for certain type of tasks. And currently we are all building theories like independently. There's only recently people started collaborating. 100 years ago, it's single author papers were the most important, right? Now you see papers with 100 authors. I don't know if they're better than the ones that were written 100 years ago, but still, that's now if we can create super intelligence, an institute or whatever, where each of us will be carrying out small computational tasks and will be together able to carry out more complex tasks, that would be spectacular. Now, if that's possible. So like, let's say I'm expert in, variational principles. Somebody is expert in doing linear algebra. Somebody else doing differential geometry. And then we all like together trying to solve tasks. I don't know if we're getting closer or further away from that, but if that would be possible, then we would remove constraints of the size and we would be able to create this higher level of intelligence where people would be collaborating and developing theories. We are not there yet. So as of now, everything that's been written on the archive, every single person can understand. And I don't think there's actually any difference between us. We just have different trainings, we learn different skills, but I'm pretty sure each one of us can understand every single paper on the archive if we put enough effort. So
you mean there is no point in duplicating?
Yeah, right, for now. But once we pass that point, once we create a phase transition where collaboration becomes not only preferred algorithm, but the required algorithm to make progress. Like, for example, individual cells cannot do differential equations, right? More primitive organisms cannot do that, but we can. So can there be some computational tasks that each one of us individual cannot do, but we as a, some group, I don't know, 100 people can? That's an interesting question. I don't know. And that's kind of what we are always talking about here, phase transition. Can we create this super intelligence just by connecting intelligent people?
That's interesting.
If that's possible, and then make it hybrid to the artificial intelligence. So don't memorize useless stuff because it's all in Google, it's all in ChatGPT, but just try to work with something that ChatGPT cannot do and Google cannot do, and that's more creative task. So that brings us back to the discussion of creativity, which I'm sure at some point we'll come back to. Okay, so maybe then I'll try to pitch the second part of the question. And well,
I suggest then we touch first the second question, and then we get about science and scientific approach, and then we get back to education. Sure. So
sure.
The second question was, are there limitations of scientific methods, and what are they?
Right, and we kind of started talking about this. So there is there's a red line that people like to draw. I think this red line is always like, don't model this and model that. Don't discuss this and discuss that. This is beyond science, so don't talk about this. So I think all those red lines are just absurd, and we should never, seriously think that there's something that we should not discuss. That would be a constraint imposed on us that is just like making neural networks shallow, or don't think about this and think about that. So all those...
Sorry, can you please say it again?
Right. So there are two aspects to the question of what kind of constraints, what scientific method cannot do. And one constraint is imposed on us from the outside, but by the society, mostly by other people. They would say, well, do not use scientific methods to model this or that. Religion may impose a constraint saying, okay, there are certain questions science can never answer, so don't even attempt to answer. And so I don't think this is a real constraint. This is a social constraint, and should be removed, right? So we shouldn't. It's hard in practice to remove it because you should always understand the reasoning for introducing those constraints. But if they are removed, then they're not. They're outside constraints, social constraints. Now, but then the question is: there really something that science can never give answers to? And I think there is one, and there is one because whenever you construct a theory in the proposal that I made, you start with the mathematical framework, right? So it's your starting point. This is your axioms. You always make assumption of what this framework is. Now, and everybody can always come to you and say, well, how do you justify this assumption? Okay. And the point of mathematics that this is like axiom. You do not justify. You assume it and then see what it gives you. And so I don't think that question can ever be answered. For example, in the model of the universe as a neural network, you can ask the question, why neural networks? Why this particular framework, mathematical, that should be used? This is beyond what the theory can answer. But once it made an assumption that the world is a neural network, then you can do whatever calculations and get your results. And it's not only for the, let's say the standard model of particle physics, right? Makes an assumption that the universe is made out of fields that obey the laws of quantum mechanics. Okay, it's an assumption. you cannot question that assumption within the framework of the theory. So you cannot say, okay, but where do the fields come from? Or why is it quantum mechanics that you make an assumption, and then given that assumption, you obtain results. So that's a sharp cutoff to the type of questions that you can ask. Yeah.
I got to ask, relating to space, how can we conduct an experiment in space, so to speak? So because what I find is that I'm basically just an observer of whatever is inside space. So it could be a planet, a star, nebula, et cetera, et cetera. But I don't see how I could create an experiment inside space. You know what I'm saying?
Well, I think once you. Sorry.
Yeah, well, no, I'm thinking out loud, so to speak. But,
right. No, I think experiments are okay once you assume what your framework and what your theory is.
Yeah, but I can't do a three-dimensional experiment inside the universe, so to speak.
Well, okay, so that's a bit different question, but are there always limitations?
Okay, there you go. There you
test,
go. Yeah.
Even if you already have your theory written out, are there limitations? There are always limitations. There's always something hidden. There's something you do not directly observe, and I've started with this, with the gluons. You do not directly observe them. There are limitations to what you can observe, but it doesn't matter. It's still consistent. So those are experimental limitations. But what I'm saying, and I think what Katya was asking, is theoretical limitation. There's certain questions. It's not just I cannot in principle observe, but they're just not questions that are possible to answer within the given framework. They're outside of it. They're assumptions that you make.
Yeah.
Now, like for gluons or some hidden space or hidden variables, maybe I will eventually design a clever enough experiment, and it will test and see that hidden variables or whatever it is, but not something else. It's okay. But so there's no red lines, but there are certain red lines to what we can never ask using the scientific methods as we formulated them. It's the assumption of the theory.
Yeah, that's what I'm getting.
Because that's kind of, and it can be any assumption at all. I mean, it's just because it's an assumption, you do not prove it. Yeah.
Right. Got it.
Test.
Rebel, you were saying something or no?
Oh, I was trying to test my video. I can't see what's happening.
Okay.
With my audio, but I can hear.
Okay. Okay.
There is a hand raised again. Alexander wants to say something.
Yeah, it's also about a recent discussion or note from you, Vitaly, about usage of AI in science. Yeah, that we have reached the limit of human brain, so to say, in physics, for example, and further on we can only go with AI. So the question is, what this AI, assuming this will be neural network?
I think I probably misspoke. I don't think we reached the limit. I don't think we reached the limit.
Okay. Maybe I misinterpreted your words.
Yeah. So I don't think we missed a limit. It could be that by just creating this, super intelligence connected people, we can make progress faster, like having more, better learning efficiency.
It's not about today's comment. It was in the chat. You quoted one of AI's fathers who referenced your article, remember? That further on we can exploit AI to discover new theories, let's say.
Oh, yeah. Well, but it's like a tool, right? So people discovered pencil and paper. And then they were able to write better theories and faster. Then they discovered computers, and then they can, do more calculations. Now they discovered an AI. This is a tool. This is a tool that is kind of you can use or not use. The phase transition to making a collaboration of people is a harder one. It's like moving to the next level.
Yeah,
right?
But even if we don't have phase transition, we can still have a progress using AI, right? Because it will enforce
as a tool.
our abilities
As a tool.
Yeah.
As a
If you
tool.
think about this AI, what will it be? So which space will it be operating in? Will it be a space of mathematical statements, or with some loss function of what? Can we brainstorm on this? If you take a neural network and ask it to derive a physical theory, something.
Right.
Yeah.
Okay. Well, that's it's a good point. Okay. So now, before I was claiming that all the theories were derived and conceived in a single brain, right? Basically,
yep.
Mostly. Now I'm arguing maybe with the help of AI, we can do it better. That's true. Maybe if we all merge into a single, super intelligence, we can do it even better. But Alexander asking, maybe we can just create AI that will do that job for us. We can just create a big enough AI, smart enough AI. We just code it, and then it will just do all of the development of theories for us. Well, but for that to happen, we have to have AGI, at least.
Why AGI? Why not regular neural network? Let's say very big one.
Well, okay. So we think that when we develop theories, we are kind of doing the most advanced work our brains can do. So now a person without 20 years of education will not be able to write modern theories. And so we should, whatever AI does, if you want AI to just even match that, somehow they should have this intelligence that we have. It may not be able to do other very intelligent things that we do, but at least that. So I'm thinking that it would have to be smarter than us. Now, of course, smartness is not like one axis. So it may be good in creating theories and then horrible in making jokes or talking. So then you wouldn't call it maybe artificial general intelligence. I would still call it pretty intelligent network. So I haven't seen any evidences for artificial networks to actually creating useful theories, but they are doing useful calculations, and they are simplifying our analysis of the physics that we already know. But they are simplifying the calculations, just like computers. Allowed us to do calculations we were not able to do before. Now with AI, we can do some simulations that we were not able to do before.
But developing a theory isn't just basically a search in the field of mathematical statements.
You would think so, but it's a huge space, right? So
huge, it may be very
it's expand. Yeah. Okay, so I had that idea in my youth that maybe you can just write a code. I actually wrote a paper about this numerical search from fundamental theory, where I would envision there would be a computer that would be like searching in the space of theories, and the space of theories is very huge, but maybe it will just pay attention to the constants, fundamental constants, try to see connections of that, trying to reduce. We have lots of fundamental constants that we call fundamental, but maybe there's some intrinsic connection of that. And so in principle, it is possible. So maybe with the AI, it's even easier to do. But there is still an exponent that you need to fight. And so
it's
I know
much
that
everywhere, the exponent, right?
What?
The exponent is pretty much everywhere.
Right. So somehow it, but usually, if you have your algorithm that scales exponentially with something, then very soon you just won't be able to run it. And
but
so
if human brain can in some way do such a search, what's the principal difficulties?
Because we have billions of neurons. Just you're right, absolutely, yeah. So
does it mean that AGI has some heuristics that allow it to be very computational intensive, if efficient?
Well, yeah. So some architecture that was developed that turned out to be correct, but it's not just architecture; also the numbers, right? We have billions of neurons. So maybe we can get the right architecture, but without having billions of neurons, we are not going to be. Yeah. So I don't know. I'm not saying that this is a dead end, but I would, if we get into that direction, if we're able to search with theories, at least for hints, right? So maybe AGI cannot fill all the gaps, but just give us a hint to where to look, right? So for example, in the last 50 years, people were looking in the direction of string theory and supersymmetry. And it turned out to be, a not very productive direction, given the top amount of resources that was put in there. Of course, lots of was developed, but given enough resources, you can start with any idea. And so maybe AI would be, hinting us, do this and don't do that. Make this assumption, don't make this assumption. It's a very interesting. Is it possible to create AI physicist that I'm sure we're not far from that, but I don't know if it's 10 years or 50
what would
years.
be the loss function for such networks, let's say?
Well, okay, so that comes to Occam's razor, right? So there has to be evaluation, some function that evaluates the complexity of a theory. For some people, it would be the number of free parameters, so that your theory produces. So number of constants, fundamental constants. That's why I was interested in constant. But for other people, it may be not that, but the number of symmetries that you are identifying. That's why we are working on identifying symmetries. But usually it's all of the above. Every single clever idea that people came across, I think, can be put in as a term in the loss function. Good. Katya, we drifted away.
I tried to.
We drifted away as usual to some orthogonal topics, right? Maybe not.
Yeah, I tried to pull back to what I was trying to say. Okay, let's try to approach it from another direction. In which can we rely on scientific methods, or can we rely on science in every situations? I mean, there are some recent examples with some stories with corruption about COVID vaccines, and lots of discussions that were referring to some scientific approaches. But we can take some approaches in psychiatric practices from, I don't know, 70s or maybe 60s, where they cured some mental illnesses with electric shock, and I think that was assumed to be it was assumed to be scientific at that point of time. So how can we make I don't know, ethics or moral or just sentient choices in such kind of situations? What do you think on that?
Well, first of all, science is corrupted to bones, just like anything else, where the money is. So because of the corruption, not the best ideas usually survive, and those ideas that are backed up by people who have influence. And that is why in the past we had some horrible non-scientific theories that were taken as scientific theories, and were actually, people were playing with them, writing papers, and the only way out of it is to actually impose the rigor into this scientific developments, and there has to be certain standards before we get to moral standards, and there has to be just standards of what it means to write a theory, proofs, how to conduct experiments without cherry picking, without hiding facts. It happens all the time in all branches of physics right now. People try to get money for their next grant. They change data it's a real problem of corruption, but it's not unique to science. It is everywhere. I hope at some time we'll discuss, for example, politics, and then how we apply science to politics. But that is another place where everything is really corrupted. So now I don't think there are any limits to where science should be applied, the honest science. But unfortunately, many people try to claim that something is scientific or science when it's not. And we see it all the time. And that we have to be careful with that. How to objectively tell people that this is science and this is not science without actually suppressing the new ideas. It's a very difficult question. Now, journals are supposed to do that, right? So you submit your idea to a journal. Journal should send it to the peer review, right? Peer review idea, right? They send it to your peers, and then they should objectively evaluate the paper and give a honest opinion about it. What happens very often, they get a paper, they not trying to see whether it's science or not, they're trying to see whether it conflicts with their theories. And then it becomes corrupted. So then they make your decision of accept or decline a paper, not based on what's written in it, but based on how I will benefit from it. And the same for grants. When the people apply for grants, not a very honest system.
Who does the peer review process? And do they have a panel or is it?
No, the peer review scientists review works of other scientists. So I get papers, I review them. They get my papers.
Okay.
And the role of journals is actually to make sure that it is, as transparent as possible. There are no bias in reviews, and some journals are very good in it. Other journals are very bad in that, and there is lots of good examples of like person getting a Nobel Prize for the paper that was rejected from a journal for some stupid reasons. And so yeah, this process is not pure. Now, can it be improved? Can the peer review can be improved? That's an interesting question that we should discuss. But it's more like about honesty, right? So it also applies to politicians. How do we make politicians not lie to us all the time, right? How do we change their objective function so that lying is not beneficial to them? How do we make an objection loss function, objective function for the referees so that it is beneficial to them that they are saying the truth in their referee reports? How do we, and it applies to politicians, scientists, people in general. How do we do that? That's actually a long discussion that we should at some point have.
A long discussion.
Yeah, it's actually one of the things we discussed in the chat was this logarithmic democracy that was proposing. So when we discussed politics, I would like to discuss that and then say how that may help solve some of the problems we just discussed.
I think that the ranked voting choice system is also a good.
Right. We discuss other things as well. So I mean, there has to be a whole new meeting dedicated just to applying scientific methods to politics in the context of the neural network or not. Yeah.
I recently saw some, it just was in some titles that a person who invented lobotomy, lobotomy?
I don't know.
Lobotomy.
Come about.
Lobotomy, yes. He got the Nobel Prize. I don't know if it's true or not. I didn't check.
Right. No, the more recent example of that woman who got a Nobel Prize for basically for COVID vaccine, right? Mm-hmm. And she was not accepted by by the scientific community. She was rejected because there we go. All right. This is just an illustration, but you have to understand that this illustrates a real problem in the entire system of how scientific work is done. So we are like touching the tip of the iceberg. What is science? But the scientists themselves don't know what science is and don't know how to properly do it. So they they're biased when they evaluate science. They also create like mafia groups. Mafia is not. I haven't used the word. That's one of the people I respect used it. So there is a mafia of string theorists. Actually, I have total respect to string theorists, but I know people who have total disrespect to them. They call this a mafia of string theorists who just cite themselves, give grants to themselves, and and because of that, they're everywhere in the news. Now, I don't think it's that bad, but it is a problem. And again, a problem that is only one type of ideas are being entertained and not others because of this corruption-like approach. But the other approach, the reason why many other approaches and theories are not explored is because people often call a theory something that is not a theory, something that's not science. And so that word is also has been used in the wrong contexts, and very often something that is what people call metaphysical, that doesn't really have science behind it, was presented as if it was a real scientific result. And so and
Could
because
you give
of
an
that,
example of such theory?
If you go to our group, there are a lot of people who post their works and they claiming that this is the theory of everything. I mean, I don't want to give names here, but there are many people. They're usually out of academia people who are just trying to explore their ideas. But the point is, even if you're out of academia, but you follow the guidelines of what a scientific theory is, that's okay. I mean, that should be considered science, and you should be still published and get all the grants, whatever you want. But that's not happening. So usually this is just not the way the scientific development works currently. So there's a lot to change. So if you think politicians are corrupted, scientists are corrupted even more. When it comes to money, basically because there's little money in science, not nearly as enough as there should be. Should be a lot more. Unfortunately, not yet. Okay, other more optimistic topics.
What is the role of what is the role of philosophy in science? Is there any role?
But that's another thing, right? So, I mean, the philosophy is where there is no science, usually. So, originally, everybody was philosopher, but gradually, all scientists were considered philosophers, right? But gradually, we've split off. And then there's now a natural philosophy or natural science league, where you do have some standards of what kind of theories you can and cannot write, and what is the approach to scientific methods. And then there is philosophers where you just allowed to say whatever you want, and you may or may not use logic as we scientists understand it. If you use more logic, then you are a better philosopher, I guess. If you use less logic, then you can still probably be a philosopher. So I would say that this is a direction. If anything, philosophy has to be brought back to the shape where any given philosophical theory is also based on a scientific method, even if something cannot be measured or detected. So I'm okay with that. So we can call philosophical theory is based on assumptions and mathematics, derivations, and then you see at the end of the day, well, you cannot see other universes like in the multiverse, and that's okay. But I wouldn't allow if you just make claims that are not justified. Yeah, go ahead.
Yeah, I was just going to say in that regard, I've been studying consciousness, and there's a multitude of philosophers that weigh in on what consciousness is, and all the various nuances relating to it. So and their contributions to that, I think, are very worthwhile. So it's really interesting
what philosophers are good at is
the big picture. Right?
Making things very, very complex, trying to explain everything without explaining anything.
Mm-hmm.
And that is opposite to what physicists would do. We are trying to at least try to explain something. And so that's why I'm saying I think it's a better approach, because at the end of the day, you do want to explain at least something. And so if it has to do with consciousness, that really sit down and try to write down your mathematics.
Yeah.
I know about one person in the community of neuroscientists who actually tried to do that. Not completely philosophers, neuroscientists. So it's integrated information theory. And so he tried to write down mathematics, and then I can go ahead, look at it, equations, and try to see where I agree or disagree. The others will not do that. The others will just say big words, sound smart. You will feel like you understood something, but then if I ask you to repeat to what was just said, you won't be able to do that. It means you learn nothing, right?
Yeah,
it just sounds right, but it really you haven't learned, just an impression of knowing something.
That's good.
All right, Alexander, go ahead.
Does it make sense to talk about philosophy when we go outside of a theory, premises of the theory, as we discussed before? While there is no answer to the question why neural networks, right? Yes, but we have to go beyond. We have to at least pose this question: why neural network?
Okay.
Will it be philosophy already if you go outside of your premises?
I think that's a brilliant point. I think this is the way it should be done. You do work as a scientist. You write your theory. You make certain derivations, and then there are some philosophical questions that are outside of it. And philosophers' jobs is to push those questions and say, well, maybe you can still answer this question. Maybe try to look at that and that experiment or phenomena. Try to think about this and that question. And maybe then you will adjust your assumptions in your theory. You will adjust your framework. You will adjust your theory. And then after that adjustment, you will create a better theory that describes more of the phenomena. Okay, that will be already beyond your previous theory, and then you can keep pushing. So I'm not dismissing that the philosophers as useless. I'm not saying that. That's exactly their job, is to ask questions that cannot currently be answered, and then make scientists think what is beyond the modern theories. But we cannot be claiming that they are reaching any results with those discussions.
That's right.
So they can only motivate us to scientists, not us scientists, because every single scientist who is working on fundamental question is a philosopher, because he or she is asking questions that cannot currently be answered. So that's why I have a PhD, doctor of philosophy, for that reason, because asking questions that are beyond the standard knowledge. But then you should understand that giving answers to those questions still requires you to go through the painful procedure of developing a mathematical framework, doing the calculations, and then giving the answers.
So the perfect example is what we're doing right now. A philosopher would say that, I think that this space is in the form of a neural network, and now we as scientists are going to jump in and, basically find the evidence for that.
That's right.
And, and it's like the way I understand it is philosophy is the big thinker, so to speak, the big global thinker. And then we as scientists are the ones that prove or disprove, number one. And then number two, if we want to prove, then we got to go to all the other next steps of, scientific method and everything else.
No, I wouldn't put a boundary there. Here are philosophers and here are scientists. It's usually within the same person, you have both.
Okay, well, that could be.
And let me take an example of the neural network theory, right? So it seems like I took the artificial neural network as a mathematical framework and started working with it. Mm-hmm. Maybe if philosophers ask some questions, deep questions that I do not know how to answer within the framework, maybe I'll have to modify the dynamics that I assumed to something else. Okay, I know maybe not the real numbers that being propagated through the through the neurons. Maybe they are complex numbers because of such and such philosophical question that was raised. Then I do modification to my theory, and then I see what kind of new results I would obtain with that. And so trying to push and generalize or make the assumptions, change the assumptions is, of course, this is exactly what philosophers would want to do, even if their starting point is some question that seems to be out of our league currently. So, for example, what is the purpose of life, right? So it seems like very general questions, but I can, within the learning theory, I can actually, formulate an answer to that. So the purpose of life is to learn the environment. Okay, give an answer. I'm not claiming the right answer or the wrong answer, but by asking like deep philosophical questions, you can actually then guide the development of theories, and that's so yeah. So we should definitely use as much of, but we should not just stop there. We should not just say, I think that's the answer.
Yeah.
I'm sure that's the answer.
Yeah.
Okay, I know that exists and that doesn't exist. That is not useful, because that's cannot be verified independently. Katya, you're not supposed to raise your hands because you are the moderator.
I'm supposed to just interrupt everyone.
You just interrupt, yeah, just like I do. Only 2 people here are allowed to do that. No, I'm just kidding. Everyone can do that.
Yeah, okay. So what I meant initially with this question about philosophy, something different. I think you answered more about is philosophy a science, but what I meant is rather does presumptions, what is the role of presumption of the scientist in developing any kind of theory? And is there actually, recently I heard some talk of Edward Frenkel about the observer problem in math. So even in mathematics, it's I think maybe eventually it's related to Gödel incompleteness theory.
Exactly. Yeah.
So it looks like anyway there is a bias in every theory has some presumptions in as a basis.
Assumptions. I would say assumptions. You make assumptions and what your theory is, and then you do it. But you are completely right. Even mathematics is not as pure as it seems. But that's okay. I mean, you just do the best you can within the framework that is that you have. So I don't think there are any problems with this approach.
I mean that. So it means that in any case we cannot have any objective. There
are no proofs. There are no proofs in physics at all. In mathematics, there are proofs under certain very, very restrictive assumptions. You make certain assumptions, then you develop your proofs. In physics, it's not even that. You can never prove anything. You can just check and verify experimentally. And there is usually 5 sigma results that consider discovery, meaning that the probability that what you discovered is just a statistical fluke is very small. But there is a probability that somebody got a Nobel Prize or something that is not real, just statistical fluke. Very small probability, so probably not in our universe. So we're not going to have that, and that's okay. So I think yes, the math is not as pure as it seems. Physics is even worse with this regard, because it's just that there's you cannot prove anything. But that's the universe we live in, and so we are well, happy or unhappy depending of. Actually, it's good, right? There is always something to learn, and it's never-ending process.
Yeah. So finally, we come to. It looks like we are saying that scientific approach is a good approach, better than just some philosophers. Because
it's the only game in town. It's the only game in town. There are no alternatives. If you're trying to look around at the universe around you, and trying to ask any question at all, and also try to give answer, there is no other game in town.
Yeah, that's an important thing to point out. Like, we should do a thought experiment. Like, think of another way to determine truth other than the standard scientific method of like testing and observing and retesting.
And truth is even only probabilistic truth, so it's not even true. Yeah, so you know, it would be nice if we can like actually, you know, confirm something with a 100% probability, but that's not happened. Never
Well, we
happened.
can get the confidence interval within 100%.
Right, exactly. So the best we can do is to say that we are almost sure this is right. And there are no other games in town. You can there's no other frameworks that will allow you to do that. Now you can say, well, I can train a neural network that will answer certain questions about the environment, but that's exactly that, because neural network is your model. That's
okay, let's return to Ramanujan case.
Mm-hmm.
So he got some knowledge, which in some time later was proved to be, or some of them were proved to be scientific, but at that point of time, it was not scientific.
It was always scientific.
I mean, he did not get it by scientific methods. He just
you can guess the answers. I mean, look, you can dream up a theory. You don't have to. You know, when you write down a theory, it's always non-scientific. It's not based on the well. I mean, you're motivated by the experiment, but then you say, well, I want to write this. When Einstein said, "I think space-time is curved," there was no evidence for that. Okay. And he said, I think so. Okay. Was it not scientific? It was not proved, but it was based on what he knew about, you know, special relativity. It was based about maybe some experiments that have shown about precession of Mercury. I don't know how much he knew at that time. But anyways, that was not, he didn't start as that, oh, I'm writing something that I know is true. Definitely not. At some point, he wrote.
But with Ramanujan, it was more like that. I think he was.
He believed it was true because he had like other visions before that turned out to be true, right? So he had the experience of already seeing true images, and so he had a belief that what he is writing is probably true, and that was later checked experimentally. There was still no. I mean, I don't know how much he would bet on that to be true. That we should have asked him. And I don't even know if like all of the things that he saw actually turned out to be true, like all of them, or there was some that. So I can easily see that, you know, sometimes there's some information got corrupted from his, you know, visions to when he wrote it down. That I don't know. But I think that's and that's mathematics too. So physics is a simpler game. So it's always probability theory, always mathematical framework, and then at the end it's probabilities. And so I don't think there is no alternative to probabilities. That's another thing I'll say. Not just to scientific methods. There is no alternative to probability theory. And people who thought about probability theory, many people I know, actually say that they don't understand the probability theory. They can use it, but really. I mean, because, you know, you flip a coin, you flip it now, and then you can never reproduce the entire state of the universe that happened when you flip the coin, right? So the next time you flip a coin, everything is different. And so you do not really reproduce the same experiment many times, and nevertheless we still use probability theory. But it's a whole different discussion about.
Okay, I have something more to say, but okay, I give a word now to Alexander, and then I will return to my point.
Thank you, Katya. My question is the interpretation of complementarity principle by Niels Bohr from the point of view of neural network. That we can describe some phenomenon by two different contradicting theories, if I understand it right.
So which kind of complementarity? So complementarity is like two different views of the same.
Well, maybe I misunderstand it, but the idea is by Niels Bohr that there are some phenomena that can only be explained by two different contradicting theories, right? They do not match to each other, like the nature of light as a wave and as a flow of particles.
Well, okay, so you can have like two complementary description, right? You can describe something in one framework within one theory or the other, but not at the same time both. So that's kind of complementary description. So it's right now like you may hear a lot about black hole complementarity and things like that. Now I think this is off. Well, it's not completely off the topic. It's a complementary description. They can be a dual description. So another example is holographic duality. When you have a very same system, and you just have two ways of talking about it. And that's actually good. It's not bad. So you have like more ways of describing the same thing. You can describe in the holographic theories, you can describe it by looking at the boundary, like lower dimensional boundary. That's why it's called holographic. And then you can also look at by describing in the bulk. But the point is, for certain calculations, it's better for you to look in one theory, and for other calculations, and look for the other description. And that is okay. That's kind of you have two different limits. Maybe the microscopic theory is the same, but there are different ways to look at it, and we do it all the time. Right. So when you are boiling soup or it's a state of more thermodynamic equilibrium, so you will use thermodynamic description for that. But when you throwing apple, that's a different limit where the thermodynamics is not so important, and so you use some other calculations and some other tools to do that. So I think it's okay to have maybe one microscopic theory, but in different limits, you have two different emergent theories that are kind of more useful. In one limit, one is more useful, and the other one is the other more useful. So I think it is not kind of there. They're like two different limits of, I think, in which talk about the very same thing. So that's
there is not so there is not single holistic explanation, right?
Or not yet. But that's why we are saying there is quantum mechanics and general relativity. They seem to be like contradicting because we don't know when to use. Sometimes we don't know which one is more relevant, right? But if you complete it, and that's why people were working for 50 years trying to quantize gravity, because how can it be that we do not know which one to use? So even if they are Gedanken experiments, even if they're just thought experiments. And so that's why you do need to look for that more fundamental theory from which both quantum mechanics and general relativity would emerge. And I will add a third thing, because not only quantum mechanics and general relativity that puzzles me, but also observers like us puzzles me. So it's appearance of this information processing observers like us. It is in conflict with both quantum mechanics and general relativity. I don't, people say that, life will emerge, blah, 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 but I don't see how that can happen. And it's very improbable event. And it doesn't seem to be something that is realistic within a standard approach. And so I would say that three things need to be unified. The observers, the quantum mechanics, and general relativity. And that is the motivation that I had to look whether neural networks can be used to model all three. It's not completed project. I mean, there's still lots of things to be done, especially with general relativity. That's the hardest one of all, but at least that there is a possibility.
So are you saying that that general relativity could somehow be activated in a neural network, or I'm not...
Yeah, at certain limits. So you like neural networks, they learn and do their stuff, and then at some point we already discussed it, but we'll probably discuss it more. Then three-dimensional structures emerge just because it's more convenient way of information processing, and then after that there's continual learning. And so when things learn, the entropy isn't increasing but decreasing, and that's exactly what happens when you look at the gravitational system. They don't like to actually spread out through the universe; they clump.
Right. Well, that's interesting.
And so this learning dynamics goes on, and then you may get general relativity. With that, you have to get not only general relativity, you have to a lot. You have to have space-time emerge, Lorentz invariance emerge. That's a difficult one. Then you need to, on top of that, you need the general relativity to emerge, and all that is you assume some dynamics at the fundamental level, so you cannot change that. And then all you can do is to do calculations by taking ensembles, averaging, and seeing how a large collection of neurons would behave, the fundamental neurons. And so that's a difficult task, but that's the idea. The idea is that you can start with the mathematics of just actually similar idea, but the implementation is very different. Was by people who propose cellular automata, right? Wolfram is the one who's pushing this idea now, but it's been long enough. So you propose a very simple rule, and then you say, well, can from that simple rule you get everything you observe around us? Quantum mechanics, general relativity, observers. You can try that, and that's again a very difficult project, and then was not done. So and then you can just change your rule of the cellular automata maybe to something else, and then see what else you can get out of this. Now a neural network is a kind of a serial automata, but it's a very particular one. So I wouldn't call it a serial automata. It's actually more of it has two types of dynamics, like learning and activation dynamics. But for whatever your dynamical system is, just formulate what it is, write down equations, and then see how it behaves on the macroscopic scales. Very difficult task, but not impossible.
So speaking of microscopic, do you think that the neural network was born, so to speak, at the very beginning of the universe?
But that's the thing, right? You cannot answer that question because you assume that there is a neural network, okay? And you make this as an assumption. That's
but we have evidence that there is one right now, as I'm hearing it.
That's a different one, and that's a macroscopic. So let's say
I'm talking about only in space.
Yeah, if you're talking about dark matter filaments and
no, they just discovered filaments that had regular matter inside of them.
That's right, but we don't know whether this is a neural network, right? So there is a difference between graphs and neural networks. You can have something that looks like a neural network. We already talked about it last time, but we can talk about
it. Okay. Yeah. You guys have covered that. All right.
Okay. No. It's a valid point. Not everything that looks like a neural network is a neural network.
Isn't it? Okay, I'm with you.
Yeah. So you need to actually show that there is a loss function, there is a learning dynamics, there's something that's trying to optimize.
Got it. Interesting. Well, this is going to be
Katya,
fun.
you promised it's going to be 1 hour meetings. What happened with that?
No,
promise?
I didn't.
Oh, you didn't? Okay, it was my problem.
No, I'm confused about what we were going to do because I thought that 1 hour meetings was that about some other kind of meetings.
No, I think we should just finish this discussion of scientific methods as much as we can, like get all the questions answered, and then.
So I'm getting back to my point. So we are discussing scientific methods in a very general sense as the way to know. Okay, we cannot know the truth, but how can we get somehow closer to more correct view of what is
the way to model the environment, the way to model the universe. That's all we do.
Yeah. So, but in some just usual life situation at some point of time, how can what can one rely on? I mean, so we talked about corruption in politics, in science, and there is no actually border.
Well, we haven't talked about. We mentioned that they exist. Talking about them is actually giving all the evidences, showing what the problem with it, showing how to solve this problem. So it's another hour, right? So we're not going to do it now. Right?
Yeah, we mentioned that there is corruption, and so first there is corruption, then at some point of time one may get some good promising idea, but it is not yet modeled well, and so on. So at some certain point of time, I don't know what should I rely on some information that is assumed to be in scientific field, or I just do what I feel. I think this is the question of that every ordinary person is facing.
Right. So I think there is a balance between being conservative and liberal, right? So being conservative in science and like relying on the theories that were written 100 years ago and ideas expressed there is the usual approach. So because it was so much tested, because we really know so many things work, and so being very conservative is a usual approach to science. However, we cannot make progress. We can only make incremental progress with that approach. There will be no big shifts in the scientific paradigm if we are only conservative. So you should also have this entropy pumped into you. You should also be a little bit of the explore new ideas and new direction, especially when you know that you are stuck in the local minimum. And right now we are. For the last 40 years or so, there was zero scientific discoveries in theoretical physics that were confirmed experimentally. Zero. 40 years. It's a very long time. Okay, nothing that was ever discovered in the theoretical physics was that later confirmed experiment. The last two experimental successes were the detection of the Higgs boson and the gravitational waves, but they were predicted before that, way before.
Sorry, but what do you mean more confirmed experimentally?
So something you write up in your formulas, right? So some result you obtain, and then say, here is the phenomena that should happen. Go ahead and measure it, like gravitational waves or Higgs boson, and then people go build, experiment and then check it and see. Well, yeah, it looks like it's there. There was one result that was obtained in the early 80s. Inflation, cosmic inflation. I think it is confirmed experimentally. That's not a scientific consensus, so many think that there's still some doubts about that. But it still was already 40 years ago that happened. For the last 40 years, there's nothing, zero. So that's an evidence that we are stuck in the local minimum. And so any small perturbation will not take you out of that minimum. So you need really big shifts, just like what Einstein did. Space-time is curved, or what Schrodinger said. It is the wave function that has to evolve. And so those things are missing. We need those big shifts now. And there's evidence that we need that. But I will also emphasize that it is a good idea to be very conservative. But sometimes when you are stuck, you have to kind of raise this temperature, speaking in terms of learning system, and start trying, different things, crazy ideas. And the more the better.
And so why can't we use the neural network of the universe
as one of those? Yeah,
is one of those, but I think we're getting some evidence now that actually exists, and I just keep going back to this last discovery about a filament.
Yeah, well, I'm the first one to say that the neural network theories should be looked at, but I still don't think there is any discovery of learning dynamics there. It's a much harder task to show something that undergoes learning, not just evolution, which is consistent with the Einstein equations for general relativity plus dark matter plus dark energy, but learning dynamics, something that is different. So I don't think we have that evidence yet. Once we have that, great. Then we're in
well.
business.
Then how do you define learning evidence? In other words, it's going to teach itself to continue to expand, or
it doesn't teach itself. Learning is usually any subsystem learns its environment. So the information that it gets from, like you are learning, right? I'm telling you something.
Yeah.
Information that I have now also stored in your brain, right? So now entropy is going down because of that. Okay. Right. So and that's the phenomena that's very easy to define microscopically, but see how it presents itself macroscopically is very difficult. That's why it took people years, hundreds of years, to understand that there are quantum fields. It's not obvious. When we are talking, we don't see quantum fields, right?
Sure.
We don't see quantum mechanics. And so doing the calculations that show that what you see is consistent with having quantum fields and the UV scale is a very difficult exercise that needs to be done. So yeah, we know, we have all the evidence there are that we should try different ideas, but because it's so conservative and so corrupted, the system, it just stuck in this local minima. Think about dictatorship. Like, take any country which has dictatorship, right? It doesn't matter how good ideas opposition has.
Oh yeah.
We'll never try it. We'll never try it. Why? Well, because if they do try it, the system collapses, and actually it will be worse for people as well. So in Russia, we went through this phase transition in the 90s, right? So it wasn't okay. Politics will live for later discussion.
Yeah, for another.
Well, I wasn't looking for that. I mean,
but anyways, what I'm trying to say that it is clear why it is corrupted. It is clear, very clear. It is clear why it's conservative. But the best we can do is to put pressure on it so that it becomes it will becomes less and less beneficial for them to keep doing what they're doing. So we want to make sure that their loss function is adjusted so that the new ideas are promoted and explored. So
so you're getting pushback on this thing, huh?
Oh, absolutely. Absolutely.
I didn't know that. Okay.
Yeah.
By the general scientific community?
I'm not pushed back. No. So it is just takes. So there is a lot of collaborators that I have from the scientific community who are looking at this and understanding this is a promising direction. But however, most of the people who are working in the scientific communities are not allowed to explore those new ideas.
Oh yeah.
They are staying on a paycheck. They are staying on grants. They have to spend like all their time doing something that they were promised to do in the grant. So it's not that they're against this; they just don't have time to explore new ideas, and that's the problem of this scientific system, current scientific system. When actually, there was Higgs, the guy who got the Nobel Prize. He said, in current scientific environment, I would never be able to do what I did. There is too much pressure on publish some incremental results. Right. And that's another evidence that we are stuck in this local minima, and everybody actually knows about that. It's people. It's not that we are in a disagreement that this problem isn't there. We just don't know how to fix it. It seems like we have to change the whole system, and that's
not good.
Yeah. Okay. Interesting. And what I meant initially is a simpler thing, more utilitarian. I mean, from the point of view of ordinary person, there is a lot of information, about this vaccination story when there was some hot discussions on what's going on about that, and about diets. All the time there is new information, what is healthy, what is unhealthy, and so it looks like you cannot you don't have possibility to really apply some approach to choose what is really scientific and what you can rely on. So you can rely on your intuition, quote unquote, in this case. That's the only way to go. So what is
I disagree.
Here?
So I think you are expressing the common problem for what are the reliable sources to obtain information. Now, to figure out what source is reliable or not, you need to understand the subject. So the more you learn about the subject, the more you learn, the more you invest into learning the subject, the more objective and better decision, more educated decision you're going to make. So the point is, if you want to make educated decision, educate yourself. I mean, that's very simple. So yes, the virus came around. We were not prepared. People didn't know what it was. And so what people did, they went to Twitter, Facebook, started reading posts from some, I don't know,
Oh, God.
influencers. That's not the way to do it.
And they were, I observed such hot discussions, and
Yeah.
people were shouting that they are referring to some scientific.
No, but go to the.
And the problem is that not everyone, or most people, are not. You don't have just enough resources to invest to know what are the reliable sources if you are not, I don't know, epidemiologist or.
Why not spend a weekend learning? I mean, do you think that there is something beyond you won't be able to learn? I mean, there is no quantum field theories in the current background there, right? So you can learn all that. You just read the original articles. You read what they claim. You try to understand their reasoning, not what people think about such and such article, right? But what the actual articles say.
Yeah.
Then you can educate yourself.
It's not really a problem. Certainly, people can invest some people can invest their time. The problem is that with such a view of the science, it should not be allowed for anyone to enforce decisions based on what he understands or what he believes or whom he believes. And once governments, politics come into this picture, saying that, okay, we believe these people, or even probably we try to understand ourselves, and now we're taking the power of decision from you people. We're making something, reinforce some decisions.
Yeah.
And at this point, it's useless to spend my time to understand these articles. For I know that some people with probably less scientific potential, less understanding than me, they will nevertheless act and enforce some decisions which are probably not as scientific for the person who invested enough time, or for one expert they are scientific and for another not. So if the picture is completed with people who have power to enforce something, then the value in scientific method decreases.
Good point.
I completely agree, Victor. I think, but that brings to, again, discussion of politics. In general, politicians are very stupid. They have like no skills to do anything. However, they have skills to break stuff, right? And so their only job is like, just don't do any sudden moves, and then you'll be a good politician. However, they end up doing lots of sudden moves. They enforce because they think they're smart. But it's actually the problem with any person who is not very smart, but he thinks he is smart. And what can we do? Now the question is, we are working under constraints of people with power imposed on us. Does it make sense at that point to educate ourselves about virus and stuff? I think it still does, because at the end of the day, they were still. It was up to you to decide whether you want to vaccinate yourself or not, right? So there was some freedom still given to you. And the more educated you are, the more educated decision you're going to make. But with politicians, Katya, I'm feeling like we need to have a whole 2 hours discussing politics.
I'm frightened of that discussion.
No, but we got to do it, because they come in any aspects of, in all discussions we're having. And we need to know how to deal with them, and we need to know how to improve them. Okay. And we know that they are not very capable.
Will they agree to be improved?
And we know that they're not very smart, so we'll have to think how to trick them so they think that they're smart, right? And then we'll actually make them do the right thing. It's a very non-trivial game we're playing here. But since we do know a lot about them, much more than they know about us, we may still win this game. But it's a separate discussion.
Just a few words back about this vaccine story. I observed very hot discussions between I don't know, more or less, let's say, educated people who thought that they analyzed some sources and they had really some skills to do so, but there were very different opinions, and well, I don't know.
That comes to the point of the conflicts where two groups of people have very different opinions. And I claim this is one of the biggest challenges of democracy. You have two groups, two countries, two populations that have very different opinions, like opposite opinions. And then I think there is this solution of logarithmic democracy that can solve it. And then I'm not going to talk about this now, but the point is you have to make sure that one group, it is beneficial for that group to learn about the position of the other group. Not to just neglect it, but to learn. And in this case, a much more an optimal decision can be made. When you just say they're stupid, I don't want to talk to them, and then live in my bubble, and they say the same thing, not very productive. And so again, then it is yet another problem of two conflicting ideas. How do you decide who is right, who is wrong? Usually nobody is right and nobody is wrong, but what's the right balance to find?
But yes, that's very important, but another topic, I think. But here we, I mean that people are coming to very different conclusions, though it seems like they are getting some information, trying to analyze it, and so how does it happen? So
why do they come to different conclusions? Information bubble problem. They start from different assumptions, different information sources. Like, you know, the person who listens 24/7 Fox News will never agree with the person who listens to 24/7 to CNN. They will never agree with each other because they live in different information bubbles. Okay, the best we can do is break those bubbles. Okay, is to say, okay, you don't have to listen to such and such reporter to tell you the truth. Here is 2 articles you can read. Okay, here are some other sources you can look at. There's so much information on the internet which people just don't know how to read it. They just choose to read whatever sounds right to them. Then
I think with COVID, the case is also about there is not enough information because things are happening fast. There is no,
there was a lot of information. You know, all of the archive is full of information. And those are published, most of them published papers. You can go there and read them. The biology papers are not so difficult.
At which point of time? I mean, if it was, I don't know, few months after it started.
No, that's a recent data. But read about what the vaccines
But I mean the discussions that were in this hot period of time when probably there are no enough
discussions. Marie, discussions are based on somebody who had read some papers and made some conclusions. Okay, if that's the case, then you should look at the papers original, read them, and try to understand whether the conclusions agree with what written in the paper. But most of the discussions were not about that. They were like very vague opinions about very vague understanding of what is actually going on, like claims that are not justified at all. So this information, like out of the thin air, from influencers, as I said, you know, because the person has 1 million followers on Twitter doesn't make him smarter than the person who has 1 follower on Twitter or 0, and then who can read papers. And so that's understood.
I think this is a job for ChatGPT. So no, seriously, I mean, the person wants to get information and, you know, I think
Victor, you are having such a face that I feel you have some opinion on this.
No, I want to say what ChatGPT.
Well, I'm a conservative, you know.
Can I just say one thing about ChatGPT? So there is a very big danger about ChatGPT because it based its replies on probabilities. So it will always tell you the most popular opinion about
I didn't know that.
And because it's based on probabilities. What is most people said? What's written in most articles?
Right.
That is where you got. Remember, we discussed the problem of being stuck in the local minima. and the ChatGPT will make it even worse because the popular opinion will become even more popular. Okay? And then anything, any type of the critical thinking will just not move you anywhere. So you have to be careful with
That's scary.
Yeah, not using ChatGPT, but actually reading the sources and reading.
Yeah.
However, even when you read the articles, online, the actual published by people, also think about the fact that they are published and written by people who got grants. And so grant institute, whoever gave grants are determining the direction in which they should research. And so there may be bias there as well. So there's a lot of things to take into account when you make a decisions. But anyway, the more you learn, the more informed decision you'll have, right? The less you learn, the more you base just your emotions. I mean, then the less informed decision you make. So my solution for this is actually educate yourself by given the what Victor said, under constraints that are imposed on us.
Yeah, makes sense.
Yeah. All right, so we are almost at 2 hours. Well, 1.5.
Yeah, actually, I don't know. So let's decide what do we do now. We can try to touch these questions that about hidden space in cosmology,
No, I think
we
we
can
gotta
get
move
back to education, or we can just finalize it now because there is no much time left to start.
No, I just want to still answer the first question that you asked quickly, and then I think we should finish. Now, how do we teach people? How do we teach kids to actually, have use scientific methods, have critical thinking? This is not something we never teach them. We ever actually teach them to memorize results and never doubt the results. And so, and then they grow up and they do exactly that. Somebody tells them, do that, this and that horrible thing, and they just do it because they're following orders. So following orders without thinking is not a good idea. And educating people how to use the scientific methods and critical thinking has to start earlier, very early. Because when they come to college, it's already too late.
Yeah.
They do not understand what science is, and so they cannot do science. In the best case scenario, they know how to do math at least, but they don't know how it is relevant to the universe around them, right? So there's like detached part of their brains where they learn how to do math, but they do not apply math to the world around them. And so the problem is we have to do it earlier on, I think.
Oh, it's in high school is when I was taught.
Well, even earlier than that. I think
okay.
We just the way educational system works is memorize. Okay, memorize this, memorize that method. Why? They're not teaching to have doubts about theories.
Yeah, right.
If you ask some high schooler, there are Newton's laws of gravity. Are they 100% true? Are they correct? And they'll say, yeah, of course, that's what I was taught. Yeah, but they will not tell you, no, there is also, they may not be correct. Any theory can be wrong. And then there is a general relativity that makes, improves on them. So that was not taught to them. And so they're always, the way we teach them, we make them memorize facts. And the skill of memorizing might have been very useful 100 years ago, but it's not useful now at all. With Google, you don't have to memorize anything.
Yeah.
With ChatGPT, you don't even know how, you don't need to with spell check, you don't need to have, spelling skills. With the ChatGPT, you just, it can like write any text for you. Just tell what to write about, right? What it isn't there is the creativity. There's no creativity in ChatGPT.
Yeah, that's not good.
And that's what we should teach the kids: how to be creative, how to, develop their own theories of anything, not everything, anything. Right?
Do you have some ideas on what kind of teaching that could be?
Well, as I said, I mean, it's not memorizing. It's like, let's say let's pick a subject, physics, right? So they come and they say physics and say, well, today I'm not going to tell you about the physical theory. Let's discover it. Yeah. So let's from the beginning assume we are Newtons, 300 years ago.
Yeah,
What
that's-
would we do? What kind of experiments would we perform? Or let's say we had just been traveled to a new planet in some, far away, right? In some other universe, and we have no idea what the laws of physics are there. All right, so what do we do? Where do we start? How do we start discovering a law in this new system? And once they start thinking about that, trying, modeling, starting from physics, then biology, then, chemistry, biology, psychology, I think a lot more progress can be made other than memorizing. So again, I mean, I'm not saying that I have laid out a new educational program of how, but I know the things that are not working with modern kids. They just they want to Google everything.
yeah.
They want to chat GPT everything, and that's not useful.
Yeah.
So
I
anyways.
think it is also, it would be also a problem with the level of the people who teach children, because for
Teachers.
what you're talking about, you need much more talented, creative, and educated people.
Yeah, I think actually I'm gonna actually be on the side of teachers at this point. Teachers are imposed, the constraints that are imposed on the teachers are horrible. They're a new direction of, at least in US, how the educational system works, that they are not free to explore their own ideas or teaching methods. They have just said, you have to prepare kids to take SAT exam. And so then the entire school time they spend preparing for some stupid tests, and tests never tell how creative a person is. They never teach creativity. So I don't think it is so much of a teacher's fault. And so I'd be defending them here, although I'm biased because I was.
No, it's a curriculum.
But it is what imposed on them. And there is very little room to wiggle. Very little, like at least in physics, like in the university level, there's very little new that you can teach them because there's so many required courses, and then there is so much stuff when you have, and what happens at the end, you get a broad spectrum of subjects, but no depth. So it's like very shallow networks that just memorize key things. And then you ask them, I don't know, 10 years later after college, they don't remember anything. Like a good meme that they have on the internet is like, in high school, they learn algebra. In university, they learn calculus. In graduate school, they learn advanced calculus. And then they go to work and they use Excel, right? So, and that's it. So then no algebra, no calculus, nothing, just Excel spreadsheets. And that's the reality. So, and a very unfortunate reality. And that's all they need for now. So hopefully this will change, but it cannot be changed from bottom up, meaning from teachers. It has to come, more freedom has to be given to them from the
I agree.
From the administrators. Okay, on this note, we should probably wrap it up. Yes.
Yeah. Anyone? Any more thoughts, Victor?
Everybody's tired now.
I have some thoughts on teaching, but I'm afraid I will again bring it back to politics.
That's okay. That's okay. Well,
for the teaching,
everything tends to get to politics.
No, it's a very, very simple picture if you try to think about it economically, and if you try to think who is showing the demand for the education. So there are just several options really who is showing the demand. It's the children, which is impossible. They cannot show any demand. It's parents. It's kind of self-demand, which are teachers. Teachers themselves can be considered people who are thinking what to tell children. And there is always the government. For parents are not organized. There is a consensus that you cannot trust teachers, and so at this point government steps in and says, okay, we are ready to completely democratically, we will determine what should be taught to children. And so at this point, the picture, it all breaks down, and we arrive to what we see now. Probably there is another answer to this. It's scientists, not teachers themselves, but some scientists like you, Vitaly, should determine what to teach children, some kind of elitist approach to this. And so we come to again to the political decision, and there are really two options. Either we enforce something, and then it comes to politicians again, or it's like kind of self-determination, where no one enforces, where everyone is can open its own school, be it scientists or priests or politicians. Whoever wants to teach should teach and should compete. Probably compete for parents, not for children. At some stage, you start competing for students themselves, but it still starts at a certain level, at let's say 18, 16 years old. Probably you can trust them to choose. But before that, from the earliest stages, you can certainly compete for parents' attention, for the parents' choice of one or another. And again, as in many other fields, I think that my personal opinion is complete freedom is the best answer to this problem, be it vaccination or be it education. I believe in the freedom and in competition. If but to keep this from politicians is the most difficult part.
Yeah, well, with politicians, I agree. They're most evil, and we know about that. But with a complete freedom, I think it is only after a certain age that this freedom should be given. So the way university system was structured was academic freedom, right? Every professor can teach whatever they want, but not to 5-year-olds, 6-year-olds, 7-year-old. At that point, they have to acquire the basic skills of how to write, how to maybe add numbers, multiply numbers. And so maybe it is okay to enforce some kind of rules of what everybody should know, like essential things in the beginning. But sooner or later, I completely agree, there should be more and more freedom given to teachers of what they teach and to students what they want to learn. Instead of like saying, okay, you are that and that major, you have to take that and that courses. You choose what you want to. Maybe you want to play guitar and the same time learn quantum field theory, or maybe history and geography. It's up to you. There should not be, but after a certain stage. And I think we already kind of discussed that, but I think that's the main idea. First, you go through this stage of developing a common language of communicating. Again, this is like establishing communication channels in the context of the neural network theory. And once the channels are established, you use them to transform as much information as possible. And it is not a good idea at all to have everybody learn the same thing. Then you will just have copies of people having the same knowledge. How useful can it be?
Yeah.
Right? It's not useful at all. The more variance of types of skills we have, the better it is for the for the civilization, for the humanity.
Yep.
Yes.
Okay.
Okay, but wait. I also have some thoughts about
okay.
education.
Artem couldn't not had to
Yeah,
say.
because that's my topic, education. I worked in there, so I have some thoughts. Like the first thought is that who will pay for for a good education? Because right now, teachers are not well paid, and also, as I understand, modern economy in many developed countries require cheap manpower to produce goods. So why do you need to spend more money if you want cheap manpower in the future? That's the first question, and the first problem maybe. And the second problem is that you said about freedom, that teachers are constrained, and that's true, but that is closely related to the way how students get into universities and how do they get well-paid job. So usually to get a well-paid job, you need to not always, but usually graduate from some good respected university. But to get in that university, you need to pass a standardized test, which is nowadays a common way to get into university. And that standardized tests, of course, they have some advantages, some disadvantages, but it's how it works today. And so if you are experimenting as a teacher, like you may teach something really good, but that means at the same time you are not preparing your students for standardized for those tests like SAT, and that means that they will probably get lower score in these tests, and that means that fewer of them will get into universities, and that of course will be not a good statistics for a school, and you will probably get fired after that.
So let me ask the first question, both of them. I think they're important. The first one, whether we need a cheap labor and we need to produce lots of cheap labor. I think this is wrong, because very soon all the unskilled job will be done by robots. And so AI is advancing fast enough, and I don't think we will need uneducated people for any of those jobs.
Hello, everyone. Welcome to the
I
topic
disagree.
over.
What? You disagree with that? So you
I
think?
disagree with that. For example, there are many jobs that will not be replaced by robots in the near future. For example,
unskilled job.
Actually, in the beginning, everyone has been talking that about that unskilled job will be taken by AI, but now it looks different. Unskilled jobs like, I don't know.
No, it's the same. The junior programmers. Yeah, you don't need junior programmers, but you will need senior programmers.
I mean some lower medical personnel in hospitals and so on. Physical, some physical jobs cannot be done by AI.
Oh, okay.
Nursing and so on.
For now, yes, we are moving in the direction where all the simple jobs should be done by AI. But anyways, I mean, this is something we can disagree on. But the second point that Artyom, you brought up, you are saying that if I'm a single person who is trying to do something different, this will not work. Of course, it will not work. The big problem is that judging people by their test scores, that SAT is the wrong way to judge their creativity and importance for whatever they can do. It's just not the way to do it. But
no one. But I think Artyom said that no one is really understands SAT or Russian YEGE. No one sees it as a way to estimate capabilities and potential of a person. No, it's just a way to make a financing distribution looking equal. It's a way to justify the way the way tax money are spent on
that's corruption.
Education. No, nothing more.
That's corruption.
I think the conclusion.
Taxes are corruption, of course.
Oh, right. So we are discussing in a if we are to create from scratch educational system right now, you having Google and ChatGPT and everything, what would we do? And I think
I have some understanding what is probably most beneficial. It's just the principle of money following the student, and so that if we agree, if society agrees that tax money should be spent on education, then everyone is entitled to some sum of money, and everyone has the freedom to choose the university, and everyone and money just follows the student and his choice, however stupid or bright he is. and he can choose between Amish and or Christian or Judaic or mathematical or physics university.
Right.
And so it works in many areas, and
And you can do it even cheaper than that if you have online universities where very skilled professors anywhere in the world, regardless of where they are, can provide you education, right? So you don't have to travel to
yeah, it's I'm not sure it works.
well, it doesn't work yet, but I mean, at least then you can really reduce the tuition.
We cannot imagine. Let's say we cannot imagine what will be real, what students who came through this system will look like. We just even students who started during COVID started this type. We do not yet see what they are, how they come out of the system where they were restricted to online education.
Oh, they're horrible. No, we have data. We have data.
Yes, and so I am cautious to some extent.
No, they're horrible because nobody was ready. Professors do not know how to teach in the online environment. Students don't know how to learn in the environment. The only thing they figure out how to do, how to cheat. That they figure out.
I was myself teaching children in this period, and we completely screwed up mathematical school, which you know about. We completely screwed up for 1 year our course just because we were not ready and we had no understanding. But so there should be some period of adjustments, and if the system will move in this direction, but they will be different. Even if everything is successful and we try to correct mistakes and the people are prepared, they will be very different from the students who came through offline education system. I don't know.
Well, but even now, students that are offline, they do everything online. That's kind of the problem. So in a high school, they have like all their assignments online, and but I guess this is an orthogonal question to ask.
Alexander is writing in chat. I don't know, either he cannot talk anymore or he cannot.
It's a bit noisy here. Saying just one note. I saw that in business many times. Everybody demands KPIs. To top management wants to measure things, but the reality, unfortunately, is not measured well. So people just measure something and propose that as really performance measurement of business. But it's a similar thing here, I think, with tests, right? Tests are well measured. Tests cannot be misinterpreted. But if we want to measure creativity, we need other creative people who can assess this creativity of the student.
That's right. Yeah.
And that's the biggest problem, I think. Right? You can create probably a school of creative people who can evaluate other creative people, and still it will be ambiguous, right? Because I think you're creative, and another person doesn't think you're creative. So that's as for me the main conflict, right? Because people who spend money, they want measurement. They want measurement. I gave you X dollars, and you gave me this result in whatever test it is. That's clear.
Even if
not
it's
very relevant to reality, but but that works. Yeah, the system works. Same in business, right? You have to sell, or you have to improve, or you have to speed up, whatever. And that often that doesn't, especially in creative areas like programming, it doesn't work at all. But still, managers demand some KPIs, and I always argue with management. It's not measured. Whatever you measured is bullshit because you don't understand what you measure, right? But it's on the charts. It's increasing. It's whatever. Yeah, that's my note.
Yeah, I agree. That's a serious problem because if you manage some structures, some big structures, you need some tool to understand what's going on and what are all those people doing. And at this point,
there are lots of assessment tools. I mean, it's not completely fair, right? So universities create assessment tools to understand how this course was, how that professor was, how that student was, are we doing correct or not? I think the point that Alexander is making, that those assessment tools usually have little to do with something that matters. and like
Yeah,
creativity.
I mean that it's very understandable from the point of view of how the current societies work, and all things that we are discussing, they come to this problem that we need another society, another design of.
But again, I think as a Gedanken experiments, we should do that. And we should have a separate meeting for the education. Like Gedanken experiments, we start from zero in the, what do we do? How do we create a perfect system? And then if we succeed, if we convince ourselves this is the right model, then we can try to first see if it can work on smaller scales or on the bigger scales. But I think there has to be a separate meeting for the education. And
yeah, and maybe we should still start not from the education, but from the design of, I don't know, society or politics.
Politics, right.
Because as Artem mentioned, the very important thing is whom we need to grow, and for which purposes. And
I think the purpose has to be creativity. Like new ideas. So that's
I mean that this is what you think. This is not what currently accepted.
I think we discussed it in terms of like a loss function of companies, right? So they go for money. They want to create more money, more profit, not the more ideas.
Yeah.
And so because ideas are not correlated with monies, or have little correlation, we are in a wrong state, and that's why we are saying, okay, let's think about where the money would go. Let me go get education where I can get most paid instead. But if you would be getting paid for more ideas and more creativity, then there would be correlation between the two. Currently there isn't, and so yeah, we should have a discussion about that.
I would like to conclude some of my previous thoughts, like about creativity, there are different actors in economy, like ourselves. Of course, we are interested to become more creative and intelligent, but there is also like a country, a society that is interested in spending less money. So these purposes are a bit contradicting. And so if you want to make education more creative, first you need to find some source of money at the beginning. Then imagine you somehow found that those money, but then there is another thing, that creativity may cause instability that society will not tolerate. For example, nowadays, like people pass standardized tests, they then get standardized jobs, and then they produced outcome that can be calculated, and that's stability. But if, for example, you created, like you gave more creativity to people, it may be good in long run, in long-term run, but imagine that after graduation, those people with higher creativity, they cannot find like job for themselves for 5 or 6 years, and for those 5 or 6 years, those people are out of economy, they are not producing something, and that's a stress for a country, for economy, for society. And so what you suggest to spend to make education more, to give more creativity, I see it as an investment. Like you invest, or you expect to have results in the long run, but at the short run, it is a stress, it is a great stress, and the result is not guaranteed. And so I think the problem that current society is not ready for such experiments, and it wants everything to be predictable.
Well, we already had those experiments where some of the basic jobs that people used to do are no longer required. right? So many industries changed because of the robots took over or automation took over, and it always causes problems with those people who have to retrain themselves for other purposes, and it always causes a perturbation. That's for sure. I mean, there's no doubt you cannot make such a change without perturbation. It's kind of a phase transition. But the point is, once the phase transition takes place, will that new society be in the better shape? And that's, I guess, the discussion that we will have some other time. Yes.
Yeah, let's do it some other time.
That's a long discussion. Yeah,
it's a long discussion.
Thank you. Thank you, Artyom.
Okay, so I think now it's time to
All right. Thank you.
finalize.
See everyone next.
Thanks everyone. Thanks Vitaly.
Bye-bye.
Bye bye.